We have another example on the board. First, I'm going to find Z total. Because this is series circuit, I'm going to add the given impedances. I'm going to add resistance to the impedance of the capacitor. So I have 200 ohms plus Z of C 400 ohms. But remember, the impedance of the capacitor or capacitive reactance, you can call impedance of the capacitor also capacitive reactance. It means exactly the same thing. Goes always with angle of negative 90 degrees. So you cannot forget about this angle. Use the calculator and find that Z total is equal 447.21 ohms, an angle of negative 63.43 degrees. This is my Z total. In order to find I total, I'm going to use Ohm's law. I total is equal voltage source over Z total, where voltage source is equal 200 volts, and if angle is not given, angle is 0 degrees, over Z total, which is equal 447.21 ohms, and angle of negative 63.43 degrees. This is equal 447.21 milliamps, an angle of 63.43 degrees. This is the current total in my circuit. You're supposed to realize that I total is also equal to IR and is also equal to IC. Why? Because this is the series circuit. Next, we're supposed to find voltage across the resistor. In order to find voltage across the resistor, I'm going to use Ohm's law. VR is equal IR times resistance, where IR is equal 447.21 milliamps, an angle of 63.43 degrees, times the resistance 200 ohms. This is equal 89.44 volts, an angle of 63.43 degrees. This is the voltage drop across the resistor. Voltage across the capacitor is equal IC times Z of C, where IC is equal 447.21 milliamps, an angle of 63.43 degrees, times Z of C, 400 ohms, an angle of negative 90 degrees. Remember, impedance of the capacitor has to go always with angle of negative 90 degrees anytime you're looking for voltage. So, voltage or impedance. So this is equal 178.88 volts, an angle of negative 26.57 degrees. This is the voltage drop across the capacitor. In order to verify that these answers are correct, you're supposed to use KVL. KVL says that the sum of the voltage drops, right? I mean VR and VC in the series circuit is supposed to give me voltage source. So let's write voltage source is equal VR plus VC. You don't have to do this calculation, but it's always good to check. So I have VR equals 89.44 volts, an angle of 63.43 degrees, plus 178.88 volts, an angle of negative 26.57 degrees, equals 200 volts, an angle of negative 0.004 degrees. So I can say this is 200 volts because this angle is so small. That's why I'm going to consider this as the zero. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of angle negative 63.43 degrees. This is equal 0.447 lead. I'm supposed to add word lead because I have negative sign at the front of my angle, or just remember that the current which will flow in the load, I mean in this case resistor and capacitor, is going to lead the voltage source by certain angle. Okay, in this case the current is going to lead the voltage source by 63.43 degrees. That's why you're supposed to add word lead to the power factor. Okay, so this is the value of my power factor. Next, we're supposed to find the true power. True power is equal IR square times resistance, where IR is equal 447.21 milliamps to the second power times the resistance, which is equal 200 ohms. So true power is equal 40 watts. Next, I'm supposed to find the reactive power. QC equals IC squared times Z of C, which is equal 447.21 milliamps to the second power times Z of C, which is equal 400 ohms, which is equal 80 volt amp reactance. Next, we're supposed to find the apparent power. S is equal I total square times Z total, where I total is equal 447.21 milliamps square times Z total, which is equal 447.21 ohms. So apparent power is equal 89.44 volt amp. So we found everything, so we can say that the problem is solved.